Hi everyone. In this video, we will talk about TCP flow control and congestion control. So, flow control mechanism is very easy and congestion control is little tricky. But yeah, we will talk about both and you will get to know like why it is tricky and why flow control is easy. So, let's just talk about flow control first. Flow control in TCP. TCP flow control happens using the window size of receiver. So whenever you are sending some packet, then you say that my window size is this, which means if you want to send some packet to me, then take it as my window size, which is let's suppose 1000. So this flow control happens using window size of receiver. Now, don't get confused that it is sender then how it is receiver. TCP is full duplex, which means either party can send or receive. So whenever it is sending some packet, it says that if you want to send me some packet, then treat this as a window size. Okay. Now let me give you one complete example of the flow control. Let's take this as a diagram. So here I have only shown each window, like one window at each side. So this client, here client I'm assuming this is a sender, and server I'm assuming this is a receiver. Although the connection is full duplex, which means the server can also send, then I need to actually show you four windows, two windows at the client side, two windows at the server side. So ultimately there will be four windows. To avoid the confusion, we have just taken one window at each side, and client I am treating as a sender. So first phase is connection establishment, which means client will send some SYN packet and server will send some SYN plus ACK, and then client will send the ACK. Now in this last ACK, client can also send some data if it has the data. Okay. Now let's suppose it is only sending the ACK, it is not sending the data. Then till now the story is very clear. So earlier, like it will just say that my initial request number is let's suppose 100. Then server will say that see my receiver size is 800. So server will advertise the receiver size, which means that if you want to send me some data, then please use this as a receiver size. Upon receiving this, then a client will say that okay, or let me just write sender here and receiver here. So sender will say that okay, let me set my sender window size to be 800 because this is what receiver wants me to set. So it will set the receiver window sender window size to be 800. Now sender window size is set. Now it will send the ACK. Now here, if you notice, like the window size is 800, but I may not be having the 800 bytes currently, which means currently let's suppose I just have 200 bytes or 100 bytes. So suppose I have 200 bytes. So this bluish area is telling me how many bytes that I currently have. Although the send window size is 800, but I do not have 800 bytes to send. So I will do what? Suppose I do have only 100 bytes to send. I will send the 100 bytes and I will say the sequence number is 101 because first byte sequence number is 101. So I will send that. And upon receiving it, receiver will say that okay, earlier my receiver window was 800. Now my receiver window has been decreased to 600 because 200 bytes have been are there basically. So receiver window is this now. Now there may be possibility that the receiver window may again increase, which means that the 200 bytes are immediately get consumed. It may be possibility, but in this case currently I am showing you that this 200 bytes are not being consumed yet, and receiver will say that now my receiver window size is just 600, which means this 200 is not yet consumed. So the buffer, total buffer is this much, but I do have only 600 as a receiver window size. Now sender will say that okay, if you have 600 as a size, then let me reset my window to 600. So sender will just reset the window to 600. Earlier it was 800, right? Now these much byte has been acknowledged, so sender has to not worry about these bytes. So sender will just shift the window. Now suppose that sender again has 300 bytes to send, so sender will send the 300 bytes, and the receiver, as per the receiver, it has total received 500 bytes, right? 200 bytes earlier and 300 bytes just now, and out of those 500 bytes, only 100 bytes got consumed. So if it had just received 300 bytes, then it will be like basically the receiver window size will be just 300, but the 100 bytes has been consumed, so that's why the receiver window size is now 400, right? So see here, these 100 bytes are being consumed. So total buffer, if you remember, the total buffer that we started with was 800. Now I have 800, like out of 800 I have 400 bytes which are not yet consumed, and therefore I will be having 400 bytes as my receiver window size. So it will say that, see, I do have only 400 bytes to store, so please send. If you want to send, then do not send more than 400. And then sender will say that okay, but sender do not have any data to send, so sender will not send any data. Suppose it does not have any data to send. Now suppose after some time what happens, like some more byte got consumed and receiver window has been increased to 600. So receiver will say that, see, 200 bytes now just got consumed, and now my window is more open, so please send me 600 bytes if you want to send me. So receiver window is now 600. So this is the all picture of flow control. So in the flow control, it just happens using the receiver window size. So based on the receiver window, sender will keep on adjusting its window, and receiver window size will get adjusted based on the bytes are consumed or not. If bytes are consumed, that the receiver will all, if suppose all bytes are consumed, the receiver window is just the allocated buffer. If some bytes are not consumed, then receiver window will be allocated buffer minus bytes which are not consumed. So that's how the flow control happens, right? Now let's move to the congestion control, which is like more tricky than the flow control. So flow control is very straightforward using the receiver window size. First, let me answer a question that why we need to do congestion control. We already have flow control, right? Why we need congestion control? Sorry. So what may happen that suppose you are sending some data, then in between there be like in between there may be congestion in the network, right? Suppose this is the network, and in between there may be congestion. Because of that, this data is not being transmitted fully, which means suppose the packet is some packet of this data is get lost. Suppose this packet get lost, this packet got lost, this packet is arriving successfully, that is okay, right? So once the packet has been received to receiver, so receiver will send some acknowledgement based on the packet, like what acknowledgement needs to be sent. So here receiver window, like receiver will advertise its window size, like my window size is this and this much. But sender should also be not only be taking care basically of this receiver window size, it should also be take care of the congestion in the network. Which means if sender just take care of the receiver window, which means let's suppose receiver is advertising that it can handle 1000 bytes or 5000 bytes, then sender cannot send the 5000 bytes because there is too much congestion in the network. If sender sends the 5000 bytes, then what will happen, the most of the packet will get dropped, and this will be a problem to TCP again. So because of that, it has to retransmit all the packet, right? It has to retransmit all the packet, and because of that there will be more congestion in the network, and ultimately the system will collapse. So if sender is only taking care about the receiver window or about the end to end, which means about the receiver only, like this is the receiver window size, so I can send this much, then there will be like too much congestion in the network, because this will lead to too much of retransmission, because sender will never get to know the actual region, like why the packet are being lost. When receiver is ready, then why the packet has been lost. So to take care of that, we need to have a congestion control. So flow control is for end to end, right? Flow control is end to end. End to end means like only to the host, but congestion control take cares of the in between routers, in between like there in between any device in the network. So congestion control basically take cares of the in between devices, and the flow control only take cares of the total end to end only. So let's talk about the congestion control. First, how to detect this congestion? If there is a congestion in the network, then how can TCP detect this congestion? So TCP sender uses the occurrence of two events as a sign of congestion in the network. One is timeout, which means if the some packet, like if it is sent some packet and there is no ACK that this packet has been received, and then there will be ultimately a timeout, right? There has been no ACK till this point, or maybe one ACK, two ACK, not three ACKs basically. So there will be a timeout, and it has to resend the packet, which means the earlier packet must have been lost, or maybe the ACK is lost, that is okay. So either the packet is lost or ACK is lost, so anyway it has to retransmit. So there is a congestion in the network. So one event is that there is a timeout, another is that it is receiving the three ACKs, right? That's what we have discussed in earlier video also. So there are two events using which the congestion can be detected, okay? Now, there are two policies or two algorithms which help us for the congestion control. One is slow start, and basically it starts slow but it increases exponentially. That's why the full name is slow start exponential increase. Another one is congestion avoidance phase, and it is basically like in this phase we increase the window size very linearly. So that is why it is called congestion avoidance and additive increase. And if there is a congestion, then it exponentially decrease, or like it is also called additive increase, multiple decrease, something like that. So anyway, these are the two algorithms that we will be studying, using which we can control the congestion. Now these two algorithms are not separate algorithms. I mean, these are separate algorithms, but these are the phases, which means if I'm in slow start phase, then after some time I will be moving in the congestion avoidance phase, and if there is a congestion, then I will be again moving in the slow start. So it will be like this. If I am slow start, then I will move to congestion avoidance phase, and if I am in congestion avoidance, then I may move to the slow start based on the congestion. If there is a congestion, then I will again move to the slow start. So let's study these two algorithms and let's see how they communicate with each other. Which means if I'm in one phase, then how I go to the another phase. So let's see what this slow start means. So I hope the idea is clear till this point. We have defined what is a congestion, why there is a need of congestion, and now we are going to study how to control the congestion, for which we are going to study two algorithms. One is slow start, another one is congestion avoidance. So in slow start phase, what we do, we start with congestion window. So there is something called congestion window, and we start with congestion window with a window size of 1 MSS. So 1 means 1 MSS, 1 maximum segment size. Okay. Now there are few assumptions. First assumption is that I'm taking every segment as 1 MSS. I mean, I'm basically treating every segment of same size, and every segment is basically having the size of MSS. So either it can have size of MSS or maybe less than MSS, but I'm considering that every packet is having the size of MSS. Okay, which means that every packet is having, or every segment is of equal size, and the size is just MSS. This is first assumption. Second assumption is that if you are sending some packet, then although you are using the cumulative acknowledgement, that is completely fine, but every packet is also being acknowledged, being acknowledgement is sent for every packet. Which means if you are sending one packet, then acknowledgement is sent for this packet. If you are sending two packets, then two acknowledgement will be sent. So you can have one acknowledgement for two packets that we have discussed in the last video. Like we can have this, and nothing will change apart from some simple calculation. So just to have some simplicity, I'm assuming that if I have sent four packets, then there are four acknowledgements that I'm receiving. Okay. Okay, I will show you what happens if you send two segments and you are just receiving one acknowledgement. I will show you in a while. But for now, let's just assume that if I'm sending two packets, then I'm getting the two acknowledgements. Okay. So suppose this is a client and this is a server, and I want to explain you the slow start phase. So in the slow start phase, what happens? The congestion window size, which is called CWND. So as you already know, there is a receiver window size. I'm assuming that receiver is not a problem, which means I can go till whatever point I want. I mean, receiver window size is huge enough. So my actual window is basically minimum of receiver window and congestion window, right? Earlier it was just earlier, like in the flow control, actual window was just receiver window, right? This was in the flow control, but TCP does not only provide flow control. So this is the real formula, this is the right formula, this is not the right formula, which means the actual window will be minimum of receiver window and congestion window. Now let's see what happens in slow start. So I'm assuming that congestion in the, like in any of this phase, the receiver is not a problem, which means receiver window is basically good enough. Let's suppose it is quite large. It is always larger than a congestion window. Let's take this assumption, and we will do one or two questions using which you will get to know if what happens if the receiver window is less. So basically, if receiver window is less, then there won't be any problem. But currently, I'm assuming that congestion is a problem. Receiver is not a problem, right? In between routers are problem. So in the slow start phase, I start with 1 MSS and I send one packet and I will receive one acknowledgement. So once I receive one acknowledgement, then the size of congestion window will be increased by 1, which means if I am receiving an acknowledgement, then the congestion window size will increase by 1. Which means what? after one RTT, so I'm starting like this, then tell me after one RTT what will happen. So let me write it on the next page. After one RTT, what will happen? Like before one RTT, congestion window size was just one MSS. So I'm not writing MSS again and again, just one means one MSS. So after one RTT, what will happen? My congestion window will be, earlier congestion window was one, and I have just received one ACK because I have sent only one packet, right? One segment. So that's why on each ACK, I will be incrementing by one. So I will increment it to by one, which means now my congestion window will be increased to 2. Now I will send two segments, right? Upon sending two segments, I will be receiving how many ACKs? Like this is my assumption currently. Don't worry, I will relax this assumption, which means we can solve some problems where if I'm sending two segments, then I'm just receiving one ACK. Like we can do that, but for now, let's assume that if I'm sending two segments, then I'm receiving two ACKs. So what will happen in that case? In that case, if I'm receiving two ACKs, then after this two RTTs, what will be my congestion window? See, after two RTTs, the congestion window will be, earlier was 2 and it will be increased by 2. Why? Because I have received 2 ACKs. See, I have received 2 ACKs, that's why it will increase by 2. Now I'm sending 4 packets. I will get 4 packets, so that's why it will increase by 4. So if you notice, it is getting increased by like 2 power 0, now 2 power 1, 2 power 2, 2 power 3. Like that it is increasing. So I start slow, which means I am starting with just 1, but it is increasing exponentially. So that's why this phase is called slow start and exponential increase. So earlier, to start with, my congestion window size will be just 1, which means 2 power 0. After 1 RTT, I have just received 1 ACK. Now congestion window size will be 2. After 2 RTTs, I have received 2 ACKs. So my congestion window size will be 4. After 3 RTTs, I have just received 4 ACKs. Now my congestion window size is 8. Now let's do one simple modification where I'm assuming that my like I will be getting the acknowledgement after two segments. So let's suppose ACK for every two segments. Then how will my congestion window will change? So to start with, here also my congestion window will be just 1. Now after 1 RTT, what will happen? My congestion window will be earlier congestion window plus how many ACKs I have got. See, for each ACK I will be incrementing 1. So if I am sending one packet, then I'm waiting, right? I'm waiting till the acknowledgement. So what will happen? There will be timeout, and then there will be like either see, if I'm sending one packet, so, sorry, that won't be a timeout. If I'm sending just one packet, then I mean, that won't be a timeout at the sender side, the timeout will be at the receiver side. So then the receiver will wait for one more packet. If I'm not getting one more packet, then the receiver will send the acknowledgement, right? So for this first packet, how many acknowledgement I'm getting? I'm getting one acknowledgement. So till now there is no difference, which means the congestion window size will be 2. You're getting, because I just got one acknowledgement, right? Now if I'm sending two packets, now suppose if I'm sending two packets, what will happen? How many ACKs I will be receiving? I will be receiving just one ACK, which means after two RTTs, congestion window size will be earlier congestion window plus how many ACK I just got received? Just one ACK, which means it will be 2 plus 1, which means 3. Now what about after 3 RTTs? So if I send 3, right, the congestion window is 3, which means if I am sending 3 packets, 3 segments, then how many ACKs I will be receiving? For 2 I will be receiving 1. Now for this I will not be receiving, so I will be receiving only after the 4. Only after the second segment. So on average, like let me just write on average, I will be receiving basically for every 2 I am receiving 1. For every 2 segments I am receiving 1. So for one segment I will be receiving 1 by 2, and for 3 segments I will be receiving 3 by 2, right? 3 by 2 ACKs. So it means there will be like earlier congestion window is 3, and I will be receiving 3 by 2 ACKs. So it will be just 3 by 2. I mean, it won't be 3 by 2 because the ACKs can't be in the fraction, which means either there will be ACK or there won't be ACK. But I'm just taking some approximation, which means like I do not want to do very mathematical rigorously this question, but I'm just doing it with some approximation. So it will be 4.5. Now after after sending 4 or 5 as a window, then it will be again 4.5 plus I will be receiving 4.5 by 2, right? 4.5 by 2, because for every 2 I'm getting 1. So it will be some 13 or something like that, right? So it will be, I think, 9 plus 4, 13.5, like that. So anyway, my point is that, like, whatever you do, now this congestion window is not linear, which means it is always exponential. Maybe in this case like in this case it was in power of 2. I think in this case it will be in power of something, like, if you do it carefully, I think it will be in power of 1.5 something, right? So anyway, my point here is that this congestion window is always exponential, which means it's not like that you are increasing linearly. If you are getting two if you are getting one ACK for every 2 segments, then also you are not increasing linearly. You are always increasing this congestion window exponentially. So let's stick to this only, which means I'm assuming that for every segment I'm receiving one acknowledgement, and this is very standard. So even though they do not mention this, then we will take it. Okay, which means for every packet I'm receiving one ACK. So even though they do not mention this, we will take this as granted. Now I hope the slow start phase is clear, which means for every ACK I'm increasing one congestion window. One congestion window means one MSS. So every time if I'm doing it, then every time I'm increasing exponentially, and in this case in power of 2, right? So there are two phases. One is slow start, which is done. Now there is one more phase, that is called congestion avoidance or additive increase. So let's see what it is, and then we will relate both of them. So in congestion avoidance phase, it says that instead of increasing the congestion window by 1 for every ACK, we will increase congestion window by 1 for the whole window, which means it does not matter how many packets you have here. Once you receive ACK for all the packets, okay, let's suppose this is the congestion window. Once you receive all ACKs, suppose this is 1 2 3 4 5, once you receive 5 ACKs, then your congestion window will be now 6, right? You will be increasing congestion by linearly. You will be increasing congestion linearly. So let me give you an example. Suppose that initial congestion window is 4, and you will send the 4 packets. Once you receive all these 4 packets in one RTT, right? In one RTT you are receiving all these 4 packets, then you will increase just by 1. Then you will send 5 packets. Then once you receive all the 5 ACKs, then you will increase just by 2. And then you send all packets. Once you receive all packets, then you will increase just by 1. So like that you will be increasing. So if I ask you for one ACK, how much you are increasing? See, for whole congestion window, you are increasing by 1, which means for one packet you are increasing by 1 upon congestion window, which means for one ACK, I mean for one segment, if you are receiving ACK for one segment, then you are increasing this much. So after one ACK, you are increasing how much? Now congestion window side will get increased to this. I mean this means this much MSS. So this is just for any mathematical question, where if like they want to be asking, but I'm just telling you that if they ask you that for every ACK how much congestion window is increasing, then it is increasing. Like for one ACK at this point in time, let's suppose the MSS is 20 bytes or 20 kilobytes. Then at this point in time, for one ACK I'm increasing 5 bytes, right? So earlier my congestion window is 20 bytes, 20 into 4 80 bytes. Congestion window is 80 bytes. Then after this ACK, my congestion window will become 80 plus 1 MSS, right? So basically I'm increasing 1 MSS after the 4, which means after the 1 I'm only increasing this 1 upon 4. So basically, which means 1 upon 4 into 20, because this is unit in the MSS, so which means 5 bytes. So I'm increasing with the 5 bytes, which means 85 bytes. You're getting? So basically, after this 4 ACK, I'm increasing 20 bytes. After this 4 ACKs, I'm increasing 20 bytes. And now my question was, after 1 ACK, how much you are increasing? You are increasing 5 bytes. So we are increasing just 5 bytes, right? But that kind of question won't be asked, but I'm just telling you that how it is happening. So after this, like, you should remember that after the whole window, you are increasing by 1. In this case, after the whole window, you are increasing by 1 again, right? After the whole window, you are increasing by 1. That's what you need to remember. So if I ask you that after 1 RTT, what will be the size of congestion window, then you will say 5. After again 1 RTT, what will be the size of congestion window? Then the answer is 6. Like that, the answer is 7. Okay. Now let's see how these two algorithms or these two phases communicate. So let's take a very simplistic assumption that there is no congestion, which means like there is no timeout or no 3 ACKs. So what I will do, I will start with my slow start. So initially the congestion window generally it is taken to be 1 MSS. 1 means 1 MSS. Like sometimes we may also take it 2 MSS, but generally we take it 1 MSS. And there is something called slow start threshold. So the short form is SSTHRESH. So slow start threshold is one threshold that decide that after which I will be doing what? Like if my congestion window size increases this slow start threshold, then I will move to the congestion avoidance. So suppose, for example, suppose that my slow start threshold is 8, okay, 8 MSS, and I start with obviously 1 MSS. So after how much time I will be reaching to the congestion avoidance? Suppose there is no congestion, which means there is no timeout or 3 ACK. So I will send congestion window, and then I will be receiving 1 ACK. So here my congestion window size is 1. Now after receiving this, my congestion window size will be 2. I will be sending two packets. Then I will be receiving 2 ACKs. Then my congestion window size will be 4, and then I will be sending 4 ACKs. Now my congestion window size will be 8. So basically here my congestion window size will be 8. So if you just notice that this is 1 RTT, this is 2 RTT, this is 3 RTT. So after 3 RTT my congestion window size will be 8. See, initial it is 1, from 1 to like my congestion window size will happen like this, right? 8 and like this. So after 1 RTT I will go to 2, after another 1 RTT I will go to 4, after another 1 RTT my congestion window size will be 8, and then after 8 my congestion like this congestion window size will be greater than equal to slow start threshold, which I assume to be 8. Then after it will enter into the congestion avoidance phase, and then this will be 9, this will be 10, 11, like that, right? So I hope you got it. This is how it is happening. I mean, if you are not reaching to the slow start threshold, then you will be keep on growing exponentially, but there should be some end, which means you cannot forever keep on growing exponentially. So that is why what we do, we put some limit that is called slow start threshold. And once the slow start threshold is achieved, we go to the congestion avoidance phase. Here we increase linearly, right? In every RTT we increase linearly. See here, in the congestion avoidance phase, in every RTT we are increasing linearly, right? So this is what happens. Now you might be wondering that how to decide this value, which means this is basically called initial threshold. Initial threshold. I mean, there will be a threshold, like we will be resetting this threshold based on some timeout or 3 ACKs, but we need to start with some initial threshold, and this initial threshold has to be given, which means you cannot assume this initial threshold to be like some people assume this to be half of the receiver window or congestion window, but we cannot do it. So I will show you an example. So there are two thresholds, which means either like that will be initial threshold, or there will be threshold that is after timeout or 3 ACKs. Then we take the half of the window, but the initial threshold has to be given. You cannot assume this to be anything. So we will be doing question based on that. Okay. So this I kept it blank, which means you cannot assume this to be anything. That has to be given to you. You cannot assume that to be a half of the receiver window or something like that. Okay. So this is the case when you do not have any congestion, but there might be some congestion, which means let's suppose that you have sent let's suppose 4 packets, and for one of the packet you are not receiving the acknowledgement. Then what will you do? So after this for one of the packet you are not receiving the acknowledgement, but you may have received, let's suppose, timeout, or your timeout has been occurred, or you may have received 3 ACK. So if you receive 3 ACKs here or some timeout, which means if there is some congestion, then obviously you can't increase this 4 to 8. So what to do? Which means this congestion may occur whenever you are in the slow start phase, which means these red numbers are showing you the slow start phase. So congestion may occur here. maybe you reach to 8, then 9, then 10, and then congestion may occur here, right? So congestion can occur at any point, maybe in the slow start phase or in the congestion avoidance phase. But what to do when there is a congestion? So I hope you got it. This is a common scenario when there is no congestion, but if there is a congestion, then what to do? So there are different implementations. So let me show you. This is implementation 1, which says that if there is a congestion, then congestion may occur either due to timeout or due to 3 duplicate ACKs. So you should not worry. I mean, you should not differentiate because of what congestion has occurred. I mean, timeout or 3 duplicate ACKs, both are same in this case. So this is just one implementation. I mean, there are different implementation of TCP. So this implementation is Tahoe implementation, Tahoe TCP, but you should not worry about it. Okay. So name and these things. So this is one of the implementation where I am saying that either the congestion may occur or because of timeout or because of 3 ACKs. You should not care, which means both are treated equally. And congestion obviously may occur in slow start or may occur in congestion avoidance phase. So if it is occurring in congestion avoidance phase or slow start phase, then you, like, what you do, you set the threshold, to be in like current congestion window to divide by 2, and the current congestion window you set it by 1. So we will take examples, but for now just understand this flow diagram. So what we do, if there is a timeout, then we set the threshold to be current congestion window by 2. So see here, this is also a slow start threshold, this is also slow start threshold, but this value is the initial value of the slow start threshold. That should not be assumed to be anything. So some people take it as a half of receiver window, but it is not the case and it is completely wrong. So it cannot be the half of receiver window until and unless it is given. So it should be given in the question. Okay, the initial threshold should be given in question. If it is not given, then we cannot assume that to be anything. Now once there is a congestion, then the threshold is current congestion window by 2, and now we enter into the slow start phase where we say that the congestion window is just 1. Okay, so let's take some example. Suppose that TCP start the data transfer and sets the initial threshold to be 16 MSS, okay, which is given in the question. Now it is given, so you should not take it or you should not assume it to be anything unless and until it is given. If it is given, then it is good. So suppose this is given that initial threshold is 16 MSS. Now what they are saying, TCP begins the slow start phase with congestion window size as 1. So initially it is 1. Now you will be like, ideally what you should do, 1 to 2 after 1 RTT, then to 4, then to 8, then to 16, and then once it is basically reaching to the threshold, then you will be increasing linearly, 17, 18, 19, like that, right? If there is no congestion, then you should be doing like that. But there is a twist, which means there is some congestion. Now they are saying timeout occurs after 3rd RTT. So basically it was actually a long question and I have not basically written everything. So I will explain you in the words, but it is a long question. So I have just written ... but I will explain you what is that question. So what they are saying, the timeout occurs after 3rd RTT. So they are saying after 1 RTT, 2 RTT, and after 3rd RTT. After 3rd RTT, there is a timeout. So here the timeout occurs, which means ideally this should be the story, but this is not happening, which means after 8, which means once you reach to 8, there is a timeout. So let me go to the next page. Once you reach to 1, 2, 2 square, 4, and then 2q or 4 into 2, which is 8. So basically after this there is a timeout. They are saying there is a timeout. After 3 RTTs. So from here to here 1 RTTs, from here to here another RTTs, from here to here another RTTs. So after 3 RTTs there is a timeout. That's what they are saying. Now like this question is little big, so let me just explain. Now what they are saying, there is a timeout after 3 RTTs, then what you need to do according to this implementation, it says that you go to the slow start phase and you set the current congestion window, let me just write it, congestion window to be 1, and there will be a threshold. So let me just write it, threshold to be current congestion window, which is 8 divided by 2, so threshold will be 4 now, right? And now you are in slow start phase. So what to do? You will be again starting with 1, then you will go to 2, then you will go to 4, right? Like that you will be going, and once the threshold is reached, you will be again you will be basically entering into the congestion avoidance phase. Then you will go to 5, then you will go to 6, then maybe 7, like that you are going. Suppose, okay, suppose there is no problem, which means there is no congestion, and let's suppose that you have reached till 12, like that. Now suppose there is again a congestion here, again a congestion, okay. So suppose there is again a congestion here. Let me just put with the red color. Again there is a congestion, and that congestion is because of, let's suppose, 3 duplicate ACKs. Actually, this particular implementation does not care whether the congestion is because of timeout or 3 duplicate ACKs, which means it just says that if there is a congestion, I do not care. Just set this congestion window size to be 1, and the threshold to be the current congestion window size, which is 12, and divided by 2, which is 6. Right now, just go to the slow start, which means from here you will set the congestion window size to 1, and then 2, then 4, and then you should be reaching to 8. Then you should be reaching to 8, but you cannot go to 8, so you will just go till 6. Right, so you will just go till 6, and then let's suppose there is no congestion, and then it is basically moving to 7 and 8, 9, 10, like that, right? 8, 9, 10. Suppose that is the question, which means, like, question is just asking you that what happens if there is a timeout here, what happens if there is a congestion here, right? And whether the congestion is because of timeout or the congestion is because of 3 duplicate ACKs, this particular implementation is just treating both of them equally. Okay. Now there are some other implementation which treats these two events as different events. So we will look at those implementations now. See here, like, once there is a timeout, then it will reach to the slow start, then this is a slow start, then it will be, then 2, then 4, like it is increasing exponentially. Then see, this graph is exponential, then it is increasing linearly. Why? Because it has reached to the threshold linearly, and after the 3 duplicate ACKs or the timeout, it will again enter into the slow start phase. Then it will increase exponentially, and once the threshold is reached, it will increase linearly. This will what happen in this particular implementation. This is one of the version of the TCP, right? This is implementation 1. Now let's look at the other implementation. What may happen in the other implementation? So there is some implementation that treats these two events differently, which means, let me show you. Suppose that you are here in the slow start, like everything is running fine, and after the congestion window has reached to the threshold, then you will do what? You will enter into the congestion avoidance phase. That is common for both of them, right? That is common for every algorithm. But the algorithms may differ, or the implementation may differ, depending on how you are treating when there is a congestion. So what was the earlier case? If there is a congestion here, then it will say that, okay, I do not care the congestion. If the congestion, then I do not care the congestion is because of what. I will go to the slow start again. I mean, I will be in the slow start only, and the congestion window size will be reset to 1, and the threshold will be the congestion window divided by 2. That's what it is saying. Similarly, it says that if there is a congestion in congestion avoidance phase, then I will again reach to the slow start, and I do not care the congestion is because of what. I mean, either this is timeout or this is 3 ACK. Then I will just say the threshold is current congestion window by 2, and the congestion window will reset to 1. This is one of the implementation that we have seen. So let me put it aside. And let's see if there is another implementation, then how it treats these two things differently. So suppose there is a slow start, and this is congestion avoidance phase. And if the current congestion window size has been increased to the threshold, then it will go to the congestion avoidance. That is perfectly fine. So here there should not be any problem, right? If the current congestion window is like this. But what if you have the congestion in the slow start? So it will say, okay, so it, like, I mean, it will differentiate. It will say that if you have congestion, then is this because of timeout? It will ask whether it is because of timeout or it is because of 3 ACKs. That's what it will ask. If it is because of 3 ACKs, then it says that just go to congestion avoidance phase. So which means if there are three ACKs, then it will go to congestion avoidance phase. Now in this case, the congestion window size, that is CWND, congestion window size, will be set to half of earlier congestion window size. So let's suppose the earlier congestion window size was 12, then now whenever you are going to congestion avoidance phase, then it will be set to 6. So it will be half of window, the earlier window, right? See, earlier I was saying that either there is a timeout, or like this red arrow is saying either there is a timeout or three ACKs. So this is which is timeout or three ACKs, whatever is their case. Then you always go to slow start, where your congestion window will be 1, right? But in this case, the congestion window will be half of the current window, and you are going to the congestion avoidance phase in case of three ACKs. But what if you get timeout? If you get timeout, then there is a self loop, which means if you are getting timeout, then you will go to the slow start as earlier, and as earlier you will be having the congestion window size to be 1, and your threshold will be the current congestion window size upon 2. So this is same as earlier, but here there is a little change, which means if there are three ACKs, then the TCP thinks that the congestion is not much severe, and you can treat it differently than timeout. So it says that, see, congestion is not that much severe, so let me not go to the let me not restart anything, which means let me not make the congestion window to be 1. Let me just go to the congestion avoidance directly, where my congestion window will be half of current window, right? That is all. That is the difference between the earlier implementation. This is implementation number 1, this is implementation number 2, and that's the only difference. So this will happen in both the cases, which means the congestion may also occur here. So similarly, if there are three ACKs, then you will do the same thing, which means if there are three ACKs, then you will be going to the congestion avoidance phase, which means in the case of three ACKs, this will be the self loop, and in case of timeout, you will be going to the slow start. So I'm just showing with only one arrows, which means at the slow start what is happening if there are three ACKs, if there are timeout. Similarly, if there is a timeout or three ACKs, then same thing will also happen at the congestion avoidance phase, which means if there is a 3 ACK, then it will go to the congestion avoidance phase, which means if there is 3 ACK, then it will be a self loop in case of 3 ACK, right? And the congestion window size will be just half of the current congestion window size. And if it is timeout, then it will go to the slow start. If it is timeout, then it will go to slow start, where your threshold will be the half of the current congestion window, and the congestion window will is set to 1 as earlier. So let me just show with only one of the arrows, and you will get to know it from this, that what will happen if there is a congestion in the congestion avoidance phase. So congestion can occur either at the congestion avoidance phase or in the slow start, and both will be treated in the same way. So see here, I mean, the congestion may occur because of 3 ACK or because of timeout. If it is occurring because of timeout, then you will go to the slow start as earlier, right? You will go to the slow start. So congestion may occur at the slow start phase, or maybe at the congestion avoidance phase. In both the cases, you will go going to the slow start. If the congestion is because of 3 ACK, then you will be going to the congestion avoidance phase. Now the only difference is that now the congestion window size will be half of the current window. So basically I have just shown in the two steps, which means the threshold is half of the window and the congestion window is the threshold. But if you just write in the one step, which means the congestion window size will be half of the current congestion window, right? And this is same as previous, which means if there is a timeout, then you need to set the congestion window size to be 1. Why? Because this timeout is treated as a severe congestion. If there is a severe congestion, then I will start from scratch. If there is a no severe congestion, which means that if there are 3 ACKs that I'm getting, then I may start with the half of the current congestion window. So let's take one example. So let's suppose that let me take one example, that you are starting with one MSS, and initially obviously there is a slow start. So let's say that threshold that initially that you are having, the threshold is 16. So threshold is 16 initially. Let's suppose you are starting with 1, and then which means you will go to 2, you will go to 4, then you will go to 8, you will go to 16, right? Suppose there is no congestion at this point. Now you will go to 17, right? Because there is no congestion, things will go as usual. 18, 19, 20, let's suppose there is a congestion, and at the 20, so 19, 20, now there is a congestion. Okay, so there is a problem here, and this congestion is because of timeout. Now there will be a difference. Now if there is a timeout, then this is severe congestion. Now I will say, let me just reset my congestion window size to be 1, and my threshold will be half of the current congestion window size, or it will be, sorry, my threshold will be, what will the threshold in this case? Yes, half of the current congestion window size, right? So it will be 10, and I am starting with congestion window size to be 1. I hope you got it. Now let's just start it. So basically now you will say that okay, 1, then 2, then 4, then 8, then you obviously you can't reach to 16, so you will just say 10, right? And suppose this is happening, this is keep on happening, and then you go to 11, then you go to 12, like that you are going, and let's suppose that you are going till 12 or 13. So let's suppose you are going till 13, and now suppose that there is again a congestion. So at this point there is a congestion, and now suppose this congestion is because of congestion, this congestion is because of 3 ACKs. Now see what will happen. If this is because of 3 ACKs, then you will do what? Just recall it. If this is because of 3 ACKs, you will again move into congestion avoidance phase, and your current congestion window will be half of your window. I mean your congestion window will reset to current congestion window divided by 2. So suppose you are going with the 3 ACKs, you will go to the congestion avoidance phase, but your current congestion window here, you will not start with 1. You will start with what? You will start with half of the current congestion window. So let's suppose that let's suppose this is not 13, this is only 12. After 12 you are getting the 3 ACKs, then you will start with 6, right? You will start with 6, and then you will say that okay, from 6 it will be 7, then it will be 8, like that it will be keep on happening, right? It will be 8, then 9, like that. So the difference is that if you are getting 3 ACKs, then your congestion window will reset to half of the current window, right? Half of the current window. If you are getting timeout, your congestion window will be just 1, and you will start with you will start with the slow start because the congestion window is 1. That's why you are the name itself is saying that you are starting slow, which means the congestion window is just 1. But in case of 3 ACKs, your congestion window will be half of the current congestion window, and then you will be starting linearly 6, 7, 8, 9, like that, right? I hope you got it. So now let's solve one question. But before that, this is the diagram that for the example that I have just shown. So you will be increasing exponentially until the threshold. Suppose there is no problem till this point, and the first problem is here. This is the first problem, which means you got the timeout, which means you will immediately decrease it to 1, and then you are starting with 1 means you will anyway start with the slow start, right? So slow start means you will always start with 1, basically. You can remember like this. And if there is a 3 ACK, then you will be having the congestion window as half, and obviously if it is half, then it is not slow start, it is basically good start. So you will be starting with the congestion avoidance phase. So suppose that you are starting from here, the threshold will be set to 10 because your current congestion window is 20, so the threshold will be set to 10, and then after 10 there is no problem, suppose. And now problem is at 12, right? Suppose this is after 10, it is 11, it is 12. Now problem is at 12. After 12 you will be dropping it down and till the 6 only, because your current congestion window is now 6, then 7, then 8, like that, right? You will keep on going. Now let's solve this question. So this question is basically a bit interesting in the sense that here they have not given the initial threshold. So let's try to solve this. What they are saying: consider the effect of using slow start on a line with a 10 millisecond round trip time and no congestion. So they are saying no congestion at all. Okay, there is no congestion at all, which means the question should be very easy. Actually it is easy. So round trip time is given to you, which is 10 millisecond. The receiver window is 24 kilobytes and the maximum segment size is 2 kilobytes. So first write the receiver window in terms of MSS. So it will be 12 MSS. Why? Because one MSS is of 2 bytes, 2 kilobytes, and receiver window is 24 kilobytes. So receiver window is 12 MSS. Now what they are saying: how long does it take before the first full window can be sent? So before the first full window can be sent, which means before it send the 12 MSS, how long it will take? See here, that first you will start with 1 MSS if nothing is given, and then 2 MSS, then 4 MSS, then 8 MSS, and then obviously you can't jump to 16, then there will be 12 MSS. So you first of all you should not assume any initial threshold, which means you should not say the threshold is half of something, half of the receiver window. So it is never, you should not assume this threshold to 6. So this is wrong, which is actually misconception of many students. Many students think that let me just assume the initial threshold. See here, initial threshold is not given, right? So why you are assuming it to be something? And since there is no congestion at all, so why you are not in the exponentially increasing everything? Since there is no congestion, so why you want to limit yourself? So do not consider, I mean, do not assume the initial threshold to be anything. Okay, so this will be the answer. And what they are asking that how much time it will take before the first full window can be sent. So it is taking 1 RTT here, 2 RTT, 3 RTTs, and 4 RTTs. So after 4 RTTs, your receiver window or your congestion window size will be 12. After the 4 RTTs, your congestion window size will be 12. And now you will be sending the 12 window. So before you are sending the 12 window, how much RTTs you have taken? 4 RTTs. Right? Before you are sending the 12th window, window of size 12, which means you have taken 4 RTTs, which means 4 into 10, which means 12 milliseconds you have taken. Right? See here, I have the answer in this question. Like in the next slide, I have the answer for that same thing. So now let's just modify this question. Let's just assume that I have the congestion, and then what's going to happen? Okay. So let's just say that for the same question, let me just copy and paste it. For the same question, I have the congestion, and the congestion is after, let's say, after the 8. So after 8, I mean the after window size of 8, I have the congestion, and there will be 3 ACKs, 3 duplicate ACKs. Okay, so what's going to happen? See, it will start with 1, then 2, then 4, and then 8, right? And then 8. Now from 8 to 16 you can't just do it because there is a congestion, or from 8 to 12 you can't do it because there is a congestion here. Now since there is a congestion, you need to take care of that, and this is a congestion because of 3 ACKs. So what will happen now? You will reset your congestion window size to 4 because the current congestion window divided by 2, which means you will reset your window size to 4, and you will enter into congestion avoidance phase. So from 4 to 5, then 5 to 6, then 6 to 7, then 7 to 8, like that, right? And 8 to 9, 9 to 10, 10 to 11, 11 to 12. So how much RTT it is taking now? See, 1 RTT, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So it is taking 12 RTTs in this case, right? Now suppose, let's just again modify this question. Now like this answer is 12 RTTs. Now let's suppose that there is a timeout after the 8. So instead of 3 ACKs, there is a timeout, which means 1, 2. So I'm assuming implementation 2, okay? So they will give you which implementation to assume. I mean, they will define the implementation itself. So 1 to 2, 2 to 4, 4 to 8, and now let's suppose you have timeout. If you have timeout, then what to do? Then you will enter into the slow start. So your congestion window will be now 1, and then again 2, then there will be 4. Now, okay, now one thing is important, like you will enter into the slow start, and whenever you are in the slow start, you always need to take care of the threshold. Okay, if you are in the congestion avoidance phase, obviously it does not matter because you are never going to use the threshold now, right? But if you are in the slow start, then obviously you need to take care of the threshold. So what will the threshold? Threshold will be the current congestion window divided by 2. So it will be 4. So after 4, there will be like threshold will be reached, and now you will be again doing 5, 6, 7, 8, because you will enter into the congestion avoidance phase. So 12 till 12 you will be doing, and then you can count the number of RTTs here. I hope you got it. Like this kind of question has been asked in GATE, so please take care of that. Now this complete our discussion about the congestion control in the TCP. Thank you.